So from the previous classes we had, right, we've spoken about thank you, Jesus. So we talked about Web3 generally and how Web3 can help, right? So yes. So basically, sorry, excuse me. Thank you, Jesus. Okay. So what do I do today? Not directly in this class today. As in this class be wonderful. Jesus.
Amen. Amen.
Okay, so the first thing, but let's start with the hello world part. So the first thing we want to do is looking at this, right? The last class we talked about what Web3, why we choose Web3 over Web2 for some reasons, right? It's not for every reason, but for reasons whereby you want anonymity, you want transparency, you want to decentralize power, or let me say you want to decentralize authority over a certain thing, right? You want to go with smart contract, or basically you just want permanence or persistence. You probably want to use a Web3 framework or protocol to implement your work, or anything that you want to do whereby identity is crucial. And you probably want to think about how to integrate a Web3 solution to it, basically. So now let's look at what you can do to write your own applications, right? That will run just like the same way you have it in backend. Now, the difference here is that your own backend, you provision your own server, or you use a public server, maybe like AWS or Azure, and you can customize those servers to become private, or you can leave it as public. Do you get? Now, in this case now, the difference is that you are running it on the Ethereum blockchain, right? Because Ethereum was the first blockchain to support writing smart contract. It was not really the first, but it was the one that supported a whole lot of like stable and more dynamic Turing complete smart contracts. It was the first to do that. So the idea was that now that you are able to have a blockchain that supports programs that you can write, what kind of programs can you write? Now that became the challenge, right? So, but at least first of all, before you even talk about the challenges, you need to know that okay, I can do this and I can build this. So now I'll just do a bit of overview about the Ethereum blockchain. So the blockchain basically is just a set of nodes, it's a set of computers, like many computers that are connected together, interconnected, that share storage. Basically, what that means is that they have the same data shared across all of them. So whatever
What are you
happens,
defining? Sorry. What are you defining?
the Ethereum blockchain,
Okay.
what it is, yes, or the blockchain generally, just a blockchain. That's just what it is. So a blockchain is just multiple computers connected to a particular network that share data. They share the same data. They share the same storage. Basically, that's what a blockchain is. But the major difference between that and a normal server is that a blockchain is immutable and it is guided by cryptographic protocols from start to finish. That's basically the difference. So now the idea, or what is important to note at this point, is that the Ethereum blockchain now, what makes it different from other blockchains like Bitcoin as a blockchain too, is that Bitcoin was centered around transfers of value at the beginning, for financial transfers, financial interactions, financial transactions. But Ethereum went a step further and said that, okay, if I can make financial transactions of sending money from one person to another person in any part of the world, I should also be able to make use of that same computer that is initiating that transfer to run programs. I don't know if you get. So now the programs that is being run now is what we refer to as the contracts.
Okay.
So instead of, because it's, don't forget that there are still computers in the world that enable you to send money, all right, and transfer money from one person to another without stress, without barriers, without any person's jurisdictions, without anybody's permissions. Because now everything is open to anybody to see both the transfer, the transaction, but everything is based on and based off cryptographic protocols. So in this case now, we now went a step further. The person that created the Ethereum blockchain that proposed it and said that why can't we have programs that will now be dynamic enough? So instead of just saying that I can only send money and receive money? Why can't I create programs that can make dynamic decisions, such as I don't want to send money now. I want to make a loan. I want to have a loan system. Can I build a program that can do that? Can I build a program that can not just deal with money, right? But deal with every other asset as money, so that I can tokenize an asset and convert something that is of real world value, like my idea, right? And make it something that people can buy or people can buy into. So the person thought of those things, and that is why he now thought of, okay, we need programs that we can write ourselves, that will change, that will now no longer be just transferring money, but that we can also write to become something else. So those are what we call smart contracts. That's basically what we refer to as smart contracts. They are just programs that do something, but they are run by the blockchain. Don't forget that the blockchain, like I said, are still computers, right? They are a set of computers running in different parts of the world, but they maintain the same states. They are immutable, they are transparent, and they are guided by cryptographic protocols. Does that make sense?
Yeah.
Okay. So now, knowing that it's a computer, so that means you can run programs on it because it's just a computer. So now, but the program you can run on it needs to follow a particular syntax and set of rules also. Just like you have your Python that has a set of rules on how to write and run it. The same way, the program that is you use for writing smart contracts too does the same thing. So in this case, we have a programming language developed specifically for writing programs on the blockchain, specifically on the Ethereum blockchain now. And so what does that mean now? So basically what that means is that you have this, you have that, okay. So what that means is that you have this program with its own syntax, with its own semantics, right, of how to write it and how to run it. So now let's dissect this a bit. I mean, I talked about this that day, right? But let's just write it again. So the first thing you see here is that you have something called Hello World. This is just an Hello World smart contract. Very simple. You can see the first thing that is very significant here is this contract. It means that you are creating a contract. Now, this is similar to classes in other programming language, like JavaScript. Now, this is how you start a class, right? You call a class name, you use the keyword class and the name of the class, and then you wrap it around curly braces, and then you begin to define all your variables inside of it. Same thing with C++. This is how you define it. So all of those languages have their way of like defining them, and this is what you have when you look at those things. So let's start with this Pragma now, which is very important. So Pragma is what you use to specify the compiler version for your Solidity contract or program. Now, that means there are different versions of Solidity over the years. And this one is just a way of specifying that, okay, I want to use this version. Now, you know that every programming language have versions, right? That's how it is. But some programming languages don't tell you the version they use. Like, you don't need to specify it. You already know it. But in this case, you specify it in Solidity to specify that I want to use this version. And the reason for that is because every version have its changes. Don't forget, like in Python 2 now and Python 3, the major difference between them is that there are certain things that are functions. But many things are functions in Python 3 that are not in Python 2. Like your print statement is a function in Python 3, is not in function in Python 2. That's like one major significant difference. So those are changes. So if I want to use Python 2 now, I will just, even from the syntax, I can detect and see that, oh, you're using Python 2 to write your code, which is easy to know. But in this case, Solidity expects you to define the version you are using, right? So you can define the version like this, using this caret. It means that any version from 0.6, right, and greater, that's the meaning. Don't worry, we'll still talk about what this means eventually. But what you need to know is that you need to specify the version for your program. And what you do, how you do that is to use Pragma, then Solidity as a keyword, then the version you want to use for your smart contract. That's the first thing. So the next thing you then need to consider now is this contract Hello World here. Now, the contract, like I said, is you define this keyword, then the name of the contract. The name of the contract of the program is this. Then this is a variable within that contract. And this variable here is called a state variable. Now, there are three different types of variables in smart contract, in Solidity, right? We'll talk about that eventually when we get to variables too. The variable types, this is a state variable. What do I mean by state variable? It's a state variable because it is declared at the top level of the contract like this. It is not within any function, right? So that means it is at the top level of the contract. So because of that, it is a state variable. Now, that's the first thing you need to know. The second thing you need to know about this is that it is public. That means it is visible to everybody that calls this Hello World contract. Because we are using this visibility of public here, it is accessible to anybody that calls this contract. And we are specifying the data type also. So that means Solidity is statically typed. That's another thing to know. So it's a statically typed programming language. So you are specifying the string, then the type of the variable greet, which is a type of string, which is visible to anybody. So, and for visibility, you can have public, private, right? Those are the two visibilities for variables. Then the other visibility is also for functions, which we have external and internal. So that means there are 4 visibility types in Solidity. 4. There's public, there's private, there's internal, and there's external. But for the variables that you have, for variables, you have public and private. For functions, you have external and internal. Does that make sense?
Come again. You said external, internal, public, and private.
Yes. External, internal, public, and private. So public and private, like you have here, are for variables, yes. And internal and external are for functions.
Really?
We are still getting there, yeah. We'll still talk about those ones. I'm just pointing it out so that you're familiar with them, the terms, before we get to it. So in this case now, we have public. So we are making this variable public by using this public keyword, right? And then we initialize the variable with the string hello world here. So basically now this is a contract. This is a smart contract called hello world contract. We can try running this. Let me copy this. We are going to be using Remix to run our contract. So what I mean by that is, let me copy. You're going to be using this remix.ethereum.org. Let me just show you. We are going to be using Remix. So Ethereum, sorry. Okay, let me send this stuff here. Remix.ethereum.org. This is a site we'll be using to write the smart contract. You can just go to the site.
Okay.
Yep. Okay, so what's this one showing? Okay. Yes.
Why are you laughing?
No. Okay. So can we proceed? Have you gone to that site?
Yeah.
Okay. So
Okay.
now
Have you seen the site?
Yes, because you'll be writing it too.
Now?
Yes. I know your laptop.
Okay. Yeah, I'll wait.
Yeah, now. But I need to see it. I will explain some things and you will test it from your side so you can follow. It's not that hard to do, Sha. It's not that crazy. Not that difficult. Yeah. Just go to the site. You will see an interface like this. You see an interface like this when you go to the site.
Okay, it's loading. It's still loading now.
All right.
Remix IDE version 54 point. Do you know? Okay, still loading.
Okay. So how?
Oh, we should continue while it's loading.
Yeah, sure. Okay. So what I would do is I have my own remix open here, right? Already opened. So what I'm going to do is I'm going to create this one. So let me just increase the to 150% so you can see it. Okay, so shrink this a bit. No, not close. Shrink.
Um, um, Mr. Mayowa,
Sir?
please let me pick this call, please.
All right, no
Hello, good
problem.
morning, sir. I'm fine, sir. Yes, I'm in Asaba. Oh, in our school? No. Okay. Okay, so okay, is a firm in our school that needs instructors. Okay. I'll be interested. Let me know how it goes if I can manage it with my job. Okay, how do I apply, sir? Okay, sir. Okay, sir. Okay, sir. Okay, sir. Yeah. Okay, thank you, sir. I sincerely appreciate it. Yeah, bye. Okay, Gamayo, one no vessel.
All right, no problem. Are we back?
Yes.
All right. So, okay. So is it loaded now?
Okay, let me check. Will you believe it's still loading? Okay,
Oh, yeah,
yes,
now
it
let's
has
continue.
loaded.
Okay. So that means we are good. All right. So what we need to do is we need to create a file, a new file to work with. So basically, we're going to start with a simple contract, right? So if you go to the left of the screen, you can see my screen, right? If you go to the left of the
Yeah.
screen here, yes, you see something, you see a folder called contract like this. Now you can click on this create new file, this icon here, or you can right click on it and just create. So I'm going to click on this icon here to create a new file. So it will ask me for the name of the file, just like in VS Code, and I'll type hello world
Okay.
dot SQL. Hello world.sol. So in Solidity, just like you have in Python with .py, .ts for JavaScript or TypeScript, you have .sol for Solidity language. So I'll click enter, create the hello world. So you see here, there's an hello world.sol here. Do you see it? So I'll just close this. Yeah. So there's an hello world.sol here. So the first thing we need to do is we go back to the example that we have here and we copy this. So the first thing I'll copy, I won't copy the code at once. I'll copy it one by one. First thing I have is this SPDX license. Now, this SPDX license here is compulsory. We'll talk about it later, right? But you're basically using to specify the type of license for this code or this contract. And the reason for that is because every contract you write, don't forget that it is a how do I put it now? It is a it's an open source contract because it's deployed on chain where everybody can see it. So automatically it is open source. That's basically what it is. Do you get? So I think that is just easy to understand. Yeah, it's open source. So that way everybody can see. So you need to specify the type of license for that code. So the license identifier for this code is MIT license. You can use any license. You can leave it as open. You can use it MIC. You can use open source. You can use whatever. So it doesn't. You can use Apache. It doesn't really matter what you use, but it's compulsory for you to put it. So the next thing we use is this Pragma. This.
Sorry.
Yes.
Can you help me with link to this documentation?
Oh, okay. Yeah. Sorry. So let me send this to.
Can you drop it on WhatsApp, please?
Okay. WhatsApp instead. Okay. Done.
Thank you, sir.
Yes, sir. Okay. So next thing we have, like I said, is this Pragma Solidity, this, right? So we copy this, we go to the Remix IDE, then we paste this. So we are already specifying the Solidity version we want to use here, right? That makes sense. So, and that basically means that we have this compiler version greater than, so the meaning of this Pragma Solidity is that you have a compiler version that is greater than 0.8.26, but less than 0.9. Like I said, we'll explain all of this in later. So we'll talk about price, right? The Solidity compiler version in a more like solidified detail later. So now let's talk about the contract now. So I can copy this contract now and then I'll paste it inside here. So I'll paste it here. So now basically, like I explained, you have this contract hello word here, right? This is the keyword. This is the name of the contract. This is the type of the variable. This is the visibility for that variable. This is the name of the variable. This is the value of the variable, right? All of these things are like clear enough. Yeah, exactly. So now, I haven't done all of these things. Is it clear enough for you? Like the code itself, can you see it clearly?
Yeah, very, very clear.
Okay. So now the first thing we want to do, using this example still, we've written our first application, right? So now let's deploy it so you can see it. It's just very simple for you to see. I will deploy it, you will see it online, this contract here. So what I will do is I will go here. You can see this. This is the file explorer. This is the search. This is the compiler. This is the deploy view. This is the debugger. This is the Git. Well, what we are going to be using is just this compiler. So after writing this and saving it, you can save also. You will come here. You will see a button called compile hello-world.so, right? I will click on this. It will compile. Once you see green here, that means it has compiled successfully. You can see compilation successful when I hover on it, right? Exactly. So if I can also auto compile the code. So if I click on auto compile, whenever I write my code and press Ctrl S here, it's going to automatically compile it. So I don't have to come here all the time to click compile. That's another advantage of this. So yeah, so that's that. So if I click on compile this, you can see it's still compilation successful. If there was anything wrong with the code, like for instance, this code I have here that is wrong, you can see that it's not successful. It's a compilation failed with one error. So that means this code has an error that I've not fixed. You get. So, but our own contract that we just wrote is successful. Yeah. So that means I can deploy it. So after I'm done compiling it like this, right? So that means it's a compiled language, right? That's one thing to understand from here. Solidity is a compiled language also. Do you get? So that's the idea. So after doing this, after compiling it, we'll go to this view for deployment. We want to deploy the code. So what we'll do here is we'll click deploy and run transaction. So I'll click on this. And once I click on this, you will see all of this here. I already have certain codes that I've deployed, but that's not what I want. So you will see all of this code. You see environment here. The environment means how do you want to deploy it? What do you want to use to deploy it? Right? And that's the point. So in this case now, there are different ways you can deploy. You can see all of the things you have here. You have injected provider, MetaMask. We have Remix VM, Cancun, Remix VM, mainnet fork, Remix VM, Shanghai, Paris, London, Berlin. All of this simply means that there is a virtual machine that you can use to run and deploy this code. like I said, don't forget that the blockchain itself is a set of computers, right? So what this is asking you basically is that how do you want to deploy? Do you want to use your own wallet to deploy it, your own account to deploy this contract, or you want to use a predefined account, which are these ones, test accounts, to deploy it? These are just test accounts. Or you want to use any of this one from your own local machine to deploy it. So in this case now, for my own test, most times I always use the injected provider. But for this particular one that we are working with, we'll be using this one. Right. So
Sorry,
now,
let me come in. You said
okay,
when deploying, there are three options. Whether you want to use your wallet,
yes,
the
test account,
the provided test account.
yes, provided, yes. Or you want to use these ones. These are also provided for you. Like these are also test accounts, or yeah, these are also test accounts. But in this case, you have like how do I put it now? This one runs on your local machine. These are local servers that you can spin up yourself. This. They are local servers that you can spin up to deploy your account. Do you get?
Okay, sir. Yes, sir.
Yeah. So in this case now, I'm supposed to use MetaMask so that I can show you the code online. But let's run it with this first, right? So because I'll still walk you through how to set up your wallet, how to do all of those things. I don't know if that makes sense. We'll still do that too.
Yes.
Okay, so now first thing to now look at is I'm going to change this back to Remix VM Cancun here. So you can do that also. Just click it. And once you click it, you will see something load here. Then you will see an account pop up here. You get?
Sorry, is this
So
class being recorded?
Yes, it is.
Okay.
Yes. So you will see you can see that it has changed to VM, and we're still loading this. So it will give me an account what is done loading. I don't know why it's taking time. We shouldn't take this long. No, don't open this. Okay. But why is it taking time now? It's taking too long. Shouldn't take too long. So let me change back to the provider, injected provider. So you can see the provider is using a network called Sepolia Network, right? I will still run with that other one. And you can see the account here. This is a test account, right? This account here is coming from my wallet, from MetaMask wallet here. So that's why it's called injected provider. So I'm using my own MetaMask wallet. And this is the account. You can see the one that ends with 06B6. This is it. 60B6 rather. And this is the Sepolia ETH. These are the test tokens that I have on this account. And that is what is, you can also see that is showing here too, right? That same thing showing here. So the idea is I can deploy this contract now. And when I deploy it, it's going to be deployed to this Sepolia network that you see here. That's the meaning. So that's why I can select between different environments. So if I deploy to this MetaMask provider now, I'm using this MetaMask injected provider, and I'm specifying Sepolia network. I can specify other networks, right? It's still my choice. The reason why it's on Sepolia is because from my wallet, I've specified that it must be Sepolia. Now you can see that it's on Sepolia here, right? I can also specify how to do it in my own wallet. I can choose linear Ethereum mainnet. I can choose Avalanche, I can choose Arbitrum, I can choose Binance Smart Chain, I can choose Minato, Lisk, blah, 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 Base, Sepolia. Any network I want basically is my choice. So, but I'm using Sepolia because it's testnet, right? So I'm not paying actual money to deploy the contract. So that's why you can see all of this here. Then you see the account I want to use to deploy. I can select another account from my list of accounts to use. It doesn't have to be that first one. I can use any other one. So whatever account I specify from my wallet is what this one will change to, and then use to deploy the contract for me. I don't know if that makes sense.
Yes, sir.
Okay. So now all of these ones, the gas limit is estimated gas from the contract. You can define a custom gas to use for a custom gas limit for the contract you want to deploy, excuse me. But you don't really need to do that, right? And if the contract needs to have a value at the point of deployment, right? When we talk about all of those things, this is where you add the value to it, and you can then push from there. But for now, let's just start simple using the simple contracts we have and deploy. So now if I try to deploy this and I click deploy here like this, and I click deploy, you see that it pops wallet for me, right? And I confirm this like this. You can see that the transaction is loading. Look at this console here, this down part here. You can see creation of hello world pending. Let me expand this a bit. Now you can see this from creation of hello world pending to view on Etherscan. So that means that's deployed the contract for me. And if I go down here, you can see hello world at so and so here.
Yeah.
You see it now. So that means I have successfully deployed this contract. And if I click on this, you can see what is here. See the variable I have here. The variable I have here. This variable. Great. You can see it here too. And if you check this on Etherscan, Etherscan is the explorer for all the smart contract and all your transactions. Any transaction you perform on the blockchain, you can see them on explorers. There are different explorers for every blockchain, right? But for this Sepolia network that I used, this Sepolia blockchain network that I used, right? I'm going to be using, it's called what they call it, the explorer is called Sepolia Scan. So in this case, if I click on Etherscan now, just to view the transaction, if I click on this, you will see that transaction. Now, you will see the transaction here called can you see all of these things now? So this is the transaction hash. This is the status of the transaction. This is the block number. This is the timestamp, the time it was created. This is the transaction action. So I'm calling this is the function signature that I called for the contract, rather, the signature for that function there. For when I called it, right? And method by this contract. So this is my address. This address is the address that deployed it, which is my account that deployed the contract, right? So it's telling me that this is the person that deployed it. From here means the sending party of the transaction, which is my account, right? And there's a 2 also. The 2 here is this guy. And the 2 basically means that this is the address that was created for the contract. I don't know if that makes sense. This 2 here is the address of the contract that was created. That's the meaning. So then there's a value. I did not send value to it. You know, I mentioned value the other time that if the contract is meant to have value, then you are sending to it. But I'm not sending value here. Then there's a transaction fee, which is this, and I'm not sending it. So but it is already taken from at the time when the MetaMask pop up the other time. Do you get? So there's a fee you pay for deployment. There's a fee you pay for every transaction you perform on the blockchain. I think I've mentioned that before, that you pay for every transaction you perform, right? And there's a fee for that. So for that fee now, this is the fee you pay for every transaction on the blockchain. This is the gas price in way. You get now. So it's basically the same thing, but this is the fee, this is the gas price, this is the gas, this is the fee, the amount. So you can click to show more details about that transaction. So we can view it as original, as default view. So these are just the input data. This is the bytes of that contract in bytes. So it has compiled it down to bytecode. This is the bytecode that you see here. So there's a way you can convert this bytecode to actual opcodes. Don't worry, we'll talk about those ones too. So you can read this bytecode, look at the representation of this bytecode, and read it into opcode, something meaningful, something readable, something like, you know, that is readable, more readable to you than just numbers. So for that aside, so let's go to this contract itself. Let's click on this that was deployed. Don't forget that this is the address that it was deployed to, right? So we said from this address to this address. So if I click on this now, it's going to take me to the address of the contract that was deployed for me. And you can see the contract was deployed 3 minutes ago, right? It was deployed from this person to this address. And you can see the type of transaction that was performed is a what? Contract creation transaction. So this is the transaction hash. Like I said the other time, everything you do on the blockchain is backed by a cryptographic protocol, right? So this is the transaction hash for that protocol. This is the block number. This is the from address. This is the to address. This is the amount, and this is the transaction fee. So you can see there is a contract creation. So it knows that I'm deploying this for the first time. And you can see some tabs here, like token transactions, token transfers, contract, event. If I click on this contract now, I can see the contract that I wrote here. Now, the reason why I can't see it yet is because I've not verified it. There's something called verification. Verification simply means that you want to verify that you're the one that wrote the contract. So, like I said the other time, that when you write your contract, right, everybody have access to it. It is open to the world, right? But so what they now do is that instead of showing you actual code, because when you write your contract, everybody can see the code. But instead of showing you the code, what it does is it will first like show you the bytecode first of that contract. In this case, this bytecode is similar to the bytecode I showed the other time. That I said you can read this to human readable words, right? This is the bytecode. And in this case now, this bytecode here, you can convert it to the actual code. So now, if I verify this contract, let's try to verify this contract so you can see what I'm talking about. If I verify this contract here, compiler type is single, compiler version is 0.826, and now you can see the license type here. When I'm verifying, it's asking for the license type. Don't forget that we use MIT the other time, so I'll still click on MIT. These are all the license types you can use. So I'll use MIT.
Where did you click on to go to verification?
So when I went to the contract here, I should be able to see the contract itself. That's this contract here, this one, this contract that I see here.
Yes.
I should be able to see it on the Explorer here. The reason why I can't see it yet, is because I've not verified the contract that I am the one that own it. So I want to verify that truly I was the one that deployed the contract so that everybody can have access to it. Currently, this is my contract. You can see my address, right? That I'm the one that own the contract. The same address as the address in my wallet. So that means I own it, yes. But I need to prove that it is my contract. So I will go from transactions tab to contract tab. This is contract. I will click on it to take me to the contract. It's supposed to show me the contract here, but it will not show me yet because I've not verified I've not verified the contract that I truly own it. So how do I verify? I verify by defining the parameters for the contract, the version, the license, that's the compiler version, the license type that I used to create the contract. That is why he's asking me for those details. I also specify the code, the actual code that I wrote first of all. So it will compare the code with this opcode. If it is the same thing, then it will allow me to verify it. Now, let's look at the steps I just talked about now. So I will click on verify and publish, this link here. Once I click on this, it will take me to another interface entirely. It will take me to this interface saying verify and publish your contract source code, right? So now the reason why it did not show me the code directly is because it wants me to verify that I'm the one that owns it, and to also decide if I want every other person in the world to know what I've written, right? It's my choice. If I say I don't want people to see it, they will only see the bytecode that you saw the other time. That's the numbers you saw. That's the only thing they will see. They won't see the text. They won't see this actual. They won't know the logic in my code. Do you get it? They won't, even though they know the address, they won't see the logic in it. But I can decide to open it to everybody. So that's what we want to do now. So you can do this, and now this is the contract address, right? This is the contract address. Let me send it to you so that you can also check it from your end. That's the contract address. This address here. So let me send you. Wait, let me go back and send you the actual address here. This is the contract address. Let me send it to you. So you can also follow all of this. So if you try it, you will see the same thing. So if you click on that address now, you will see the same transaction here, right? So I want to go back to verify the contract. So I'll click on verify and publish. Once I click on that, I'm going to see all of this. This is the address that I want to verify is correct. I will select the compiler type. Now remember from our code, the compiler type is what? 0.8.26. Do you get? So that is what I will specify at the point of verifying the code. So I'll select the compiler type. First of all, it's a single file because it's just one file. It's not multiple files, right? I'll click on single file. Then I'll select the compiler version here. So which is 0.8.26. Do you see it? So I'll click on this too. Then I will now select the license type also. The license type in this case is the license that I specified here, which is MIT. Do you see it?
Yeah.
Exactly. So I know, don't worry, I know it's a lot, right? But just trust me, all of these things, you still do it step by step. Like when you write your own code, you will do. So I just want to show you so that you can know like the entire thing you are hoping to do. You get, because hey, it can be a lot, but it's not. This one is not even difficult yet. We've not even written anything. Once you take this verification process out of the way, you can focus on writing more advanced codes. That's the idea. So then we select the license type, which is MIT, that we know. And once you do that, you click on, you agree to the terms of service, then click on continue. Once I continue this, so yes, you can see this, verify and publish source code, this and this. So after entering the contract details, now I want to verify actually. So what I will do is, this is the details, right, from whatever I've specified. So now I want to do something. I want to enter the Solidity code. Like I said, it will now ask you for the actual code that you want to verify. Don't forget, you've deployed the code already, right? But you still need to prove that it is you that have the code. So you need to specify the actual code, the same code that you've deployed already. You now paste that code inside here, like this. Do you understand?
Yeah.
Exactly.
That is
So you paste
everything.
everything again. So that the reason for this is it will compare this code, because it will convert this code back to bytecode. The same bytecode that you saw on the page the other time. It will convert this code that you pasted here back to that bytecode and compare the bytecode if it's the same. So if the bytecodes, that's this one that you just pasted, this one, and the one that you deployed together before, if they are the same, then it will allow you to verify, to now tell you that it's successful. So that's why it needs the same source code that you deployed before again, so that you can show that, yes, this is truly my code. Does that make sense? So that's the
Yeah.
idea. Yeah. So now all of these are advanced configurations. All these advanced configurations, you can see them also here. Remember when we were deploying, I showed you that you don't need to bother about this. You can see compiler configuration, optimization, version 200. That's the same thing you can see here too. 200, default, compiler default, optimization, no, license this. Do you get? So you don't need those ones yet, but now you can see that everything is successful, right? This is the code. This is the code. So what I'll do now is I'll now click verify and publish. Once I click this, it's going to submit the code for verification. So I'll click verify and publish. So it's going to load. It's going to load exactly. Now I see this stuff here. It says successfully generated bytecode and ABI for contract address. Oh, sorry. What am I doing? What have I done? Where is this thing? Sorry. Okay. So it's going to, yes. So this is the bytecode, right? So I have this here. So definitely generated bytecode and ABI for contract address. I have this response, right? And this is the address. So it's telling me now that it has generated the bytecode and ABI for the address. So that means the bytecode is successfully compared with the one I deployed, and that means it's the same. So now that means everything is successful. And you can see the same bytecode as before. Same thing as before. So that means it's correct. Then you can see something called the ABI. Now the ABI in this case means application binary interface. This is the meaning of ABI. Let me close this so it can be clear enough. ABI in this case means application binary interface. The same way you have API, right?
Yeah.
Exactly. It's the same thing. Application programming interface. The difference basically is just this word binary and programming. It's just a term to show a difference. But the beautiful thing is that this ABI is in JSON file. So the same way you are used to passing JSON files from your normal APIs, it's the same thing you are doing with ABI. You're not doing anything different, really. Like it's the same thing. The only difference is that the structure of your ABI is always similarly the same. let me use that. Always almost the same. If you look at this ABI now, compare this ABI that I'll paste. I'll copy this ABI and I'll show you a very complex ABI like difference. So this is an ABI. Let me show you this ABI. Let me not use this. So let me show you an ABI from here. For that particular hello world now, let me show you this ABI here. This is the metadata. Now this is the ABI here. You can see how it looks like. This is the ABI here. ABI, you can see there's input, name, output, this and this. This is just the ABI, very short, right? But if you look at another one, another program like this one now, let's look at the ABI. You can see how plenty it is. This is the ABI. Because the program code is a lot, the ABI too is a lot. Because this one, the code is small, the ABI is small. So if you look at this ABI, the ABI also makes sense. It has meaning, right? There's an input, there's an output, there's a type, there's a mutability, there are all of those things. But what you need to understand, like I said, is that they have the same structure. That's the idea with the ABI. The ABI are similar in the way they look. Do you get? So you have input, you have output, you have name. If I compare with this one too, you have input, you have name, you have output eventually. This one have a lot of things. So the output is down, 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 down. You get now, but it's still a JSON format. Exactly. So I think that's all you need to know about it for now. When we start dealing with integrations, eventually you will understand it better because you still make reference to it. So now that we've done that, we've seen the ABI, we've seen the bytecode, then we see the name of the contract, which is hello world. So you see that our contract is now in line now. Yes. Are you saying something?
No.
Okay. So now that we've done this, we've successfully deployed our contract, right? What we want to do now is we now want to check that contract again. Now I'll check this contract by clicking on this. Now that I've generated the bytecode, I've verified it, right? I will click on this to go back to the contract. So once I go back to the contract, you will see the code that we wrote. Can you see it? The same code. You can see it. The same way we wrote it, the same format and everything. You can see it like this. So does that make sense now? So that means anything you write, as long as you make it available to everybody, as long as you verify it, you are making it available to every single person in the world that this contract, you have access to it. Do whatever you want with it. I don't know if that makes sense.
Yeah, it makes sense.
Exactly. So now we just wrote our first contract. We've written our first contract. We've deployed the contract. We've written our contract. We've deployed the contract like this. Now, just what we have now is that we've written a smart contract. We've deployed the smart contract. We've verified the smart contract. Just within a few minutes. And that means this contract now is live. Like you've written your code and deployed your code. And anywhere in the world, you can make reference to this code. Just like writing your code and deploying it to a server. That's what you've done. No. That's that.
Okay.
Yes. But it's not every time you want to verify your code. There are some people that don't verify their code. Some companies will write their code and they won't verify so that you can't know the logic in their code. Do you get? But most people verify their code because they believe in the open source idea, which is good, so that you want people to see. And that way, in fact, it's even good that you verify your code most times if it is not something that has to be like for private things. But if it's for public use, it's good to always verify so that people can see what it is that they are doing. That's the idea, the essence of the blockchain. And another reason is because you are doing that so that people can also see the code and vet your code. Because that way it makes it easy for people to vet what you have done and be sure that, yes, this thing is correct. Because you might have a bug there, but someone can read it and see it and tell you this is the bug. You say it happens. That thing have saved a lot of people money on, waste of people money, and has made a lot of people money too. That aside, those are smart contract auditors. That's their job. So, but let's come back to what we are talking about. So in this case now, this code that we have written, that we have here, same way, the same format and everything, we have it on chain now. So this is your first contract now. This is the contract you have written. This is the contract you've deployed. This is the contract creator. This is the hash of that for the contract creation. This is the transaction that you performed. This is the name of the contract, Hello World contract. This is the contract code. You have written all of these things. You have the ABI in this case, which you can copy. Now, this ABI is what you use to interact with this contract from the front end. That's the meaning. So if I want to call this contract now from the front end, I have something to do with it, right? This ABI is what I will use to interact with the contract. So you still need this ABI, just like that front end we used to interact with this in the back end, and it's the same concept. This ABI is what you use to interact with your contract. So it's pretty straightforward, like it's pretty straightforward to use. We've written our code, we've deployed it to a live network now, and everybody can make use of it. That's the idea.
Okay. But when it comes to verifying, you can verify now without showing your source code.
No, you want to verify. You're saying that you're automatically going to show the code. That's the idea. You don't need to verify, like I said. The way we had it before it was showing us bytecode numbers here. It's still valid. Okay. Your code has still been verified, like it has still been deployed, right? It's very valid. But the difference, I wanted you to see the code.
Okay, it is when you verify that they see your code.
Exactly.
Okay.
So it is when you verify that they see your code. So that you are basically saying that, yes, I'm verifying that I am the one that created this code and I want to put it online for everybody to see. So that's the idea. So now we have successfully written our code, but it's not every time we want to push it to, like when you are developing, like when you are testing your code, right? When you are building your application, it's not all the code you want to push online every time. You want to test locally first, right? So in that case, if you want to do that, going back to this code that we have here, we've done this Hello World, right? Let's look at a very more, something like this that actually works. So let's use this contract now. We'll test this, but we are not going to be pushing it just like we did the first one. We are going to be testing locally. So in that case, I'm going to be using the other deployment method. So, but before then, let me just copy this code, right? So what this contract does is you can get increment, decrease, and count, and decrement the count stored in this contract. So now let's try to see this. I'll just show you how to deploy this, then we'll wrap up for this one. Then we'll come in the next class to do some higher advanced stuff. So the first thing is, let me go and create a new file. Go to contracts, create a contract folder, click on create new file. I'll call this counter.sol. If I call this counter.sol, the contract is counter.sol. So inside there, I'll just paste the contract that I copied just now. And once I paste that, you can see the contract here, right? Now, in this case now, you see it's compiled successfully, but so that means everything is here. The compilation is successful. Now I want to deploy it, but I don't want to deploy using my MetaMask wallet this time around. I want to deploy using Remix, the VM. So I don't know why it's slow. Let me refresh the page first, probably because it has been open for a long time. I've been opening it since. Okay, so so I'll go back to this contract, go back to counter, right? What is it now? So go back to counter. Now this is counter, right? Let me increase this. Yes. So now I have this here, this counter. It is compiled successfully. Now let's try to deploy this. We are going to be using so you can see now we have Remix VM Cancun. This Cancun is basically, don't worry, it's just like an upgrade. It's like a snapshot of the virtual machine after year after year. Don't worry, we'll talk about that eventually. So, but the idea is that you have this VM that was selected from here. We are not using this provider again. We are using this one of this now. So I'm selecting the VM Cancun here, and you can see the address I gave to me. Now you can see there are many addresses here, a lot of them with 100 ether. All of them are test networks, test addresses, test accounts with funds that you can use to test. So I'll select any of them. I can select any one, but let's just use the first one. And then we'll deploy this contract, this same one, you can see you select the contract from here. You can see that it's automatically selected, right? If you have multiple contracts here, let's say for instance, I have something like this. If I have this and I save it like this, I can see, if I go here, you can see that there's counter and there's counter 2. Do you see it? So you can select, if you have multiple contracts here defined in the same file, you can select which one to deploy. But if I have only one, then there's no need. So, but now I want to use this counter, not this counter 2. So I'll select counter here. And once I do that, I click deploy, right? It's not going to ask me for MetaMask this time around because I'm not using my injected provider. I'm just using the VM that is provided, like I said, made available for me. So you can see that I successfully created this account, right? And now that it has successfully created this one, now what happens next is that I can interact with the contract. If I scroll down, you will see the contract here, deployed contract. So if I click on this, you can see this. All of these are functions within, this contract. As you can see here, there's a contract called counter, right? The counter, there's a get function, there is an increment function, and there's a decrease function here. You see that those are the 3 things. Now let's try to read this contract first. Isn't the idea we use for the first one, right? This is a contract. You are creating the contract like this, right? This is the data type for this contract, for this variable rather, right? For the variable call count, this is the data type. Data type here is uint256. We'll talk about data types later on. But this simply means that it's an unsigned integer. Unsigned integer type. That's what this uint256 means. The u here means unsigned. This int here means integer. 256 here means of 256 bits or 32 bytes. That's the meaning. Now, all of these bits and bytes stuff, they are low-level programming terms. If you are familiar with JavaScript, does not have it, Python does not have it. But if you are familiar with low-level languages, you'll be used to all of these bits and bytes stuff. But if you don't understand, we'll talk about it in another time entirely. Does that make sense? Right? So that's basically what we are after, this stuff. So this data type for what we are working with, we are working with uint256 data type. We are declaring the visibility as public, and we are declaring the count as the variable name. So this is the variable count of public. So that means it's publicly available, and you have uint256. Now, the reason, because of this visibility type as public, right? If you look at this now, you can see that there's a count here. This count here that you see here is only accessible because we declare this as public. So anytime you declare a variable as public within your code, within your smart contract, it is automatically available to be called by anybody. I don't know if you get the idea.
Yeah.
Does that make sense to you? That's exactly what is happening here. So now let's look at this function now. So the next thing to see is that we have a function. Now let's look at the function. A function in Solidity is simply the same way or similarly to how you have it in what they call it in JavaScript, right? Because you have a function keyword, you have the name of the function with braces, but in this case, you have other things like public. What this public does is similar to what the public does here, is for visibility. So you are simply saying that anybody have access to call this function here, and that's why you have it here also. You can see it in blue, right? Here. So then you have something called view. Now this view means mutability states. That's the idea. Mutability state in the sense that if you declare a variable as view, you are simply saying that it is not writing anything, it's only reading. So any function that is reading, that is not writing anything, remember that this is just reading something. It's not writing anything. We are not doing a write operation. Write operations in the sense that we are not changing anything. We are only reading something. Just like you are reading an endpoint, you know, it's different from a post request. A get request is different from a post request. So anytime you are getting, yeah, go ahead.
Since get is view, post will be what?
Post does not have any term. That's why you see that, for instance, this one now that you are changing something, that you are modifying the value here, you can see that there's nothing at the front of it. It's just public.
Okay.
Yeah, we'll talk about these views and we'll talk about them in detail too, because all of these things, I'm just chipping it in so that I can understand the contract. Then when we get there, We'll talk about them in detail. Do you get?
Yeah.
Yeah. So now for this view, now we are simply saying for view, we are using view because we are saying that we want the compiler to know that this function does not write anything. Now, major reason for adding view to your function is so that you can, so that the compiler can reduce the cost of gas that it's going to use. It's just for efficiency's sake. It's a way to optimize your code. So this way now, if the compiler sees that, oh, it's a view function, it can calculate the amount of gas. Like you can see 2454 gas here by the right here. Can
Yeah.
you see? Exactly. That's the compiler being able to calculate the amount of gas to use because he already knows that this is just a read, just for you to read. So you can make predictions as to how much you are going to spend to run this function. So it's for optimization, it's for optimizing your code. It's a way to optimize your code. It's one of the ways to optimize your code. So that's that. Then you see these returns now. This return simply means you are specifying that this function should return something. So as long as you specify returns here, it must return something. If I don't return anything here, for instance, you throw an error. You can see it. It's already warning me, right? Saying that unnamed cannot be made unassigned. This. So it has to return something. The moment I specify returns. So I'm now saying that now another thing you must do is the return type, you must specify it. You must specify the type to return.
Sorry, so I'm seeing two returns. I'm seeing returns and return.
Yes, this one means returns. You are saying that this function call get, right, with visibility of public, that is a view function, must return a type of uint256. That means it must return an unsigned integer.
Okay.
Yes, but this one is returns with an S. This one is return without an S. So this one without an S now, right, is where you are now actually returning the value. And the value you are returning must be of the same type as the value you specified here.
Just like TypeScript.
Exactly, just like TypeScript. Does that make sense?
Yeah.
Exactly. So now after doing this now, you are returning the count here. And once you undo this, that means you have a function called get, right? That you are returning something from, which is this. Then once you are done with that, that one is clear, right? Now, you can see that it's a read function. It's just a read operation. So now let's go to the write operations. In this case, now you want to modify the state. Remember, I mentioned that the other time that this is a state variable. And the reason why it's a state variable is because it's defined at the top level of the contract, not within a function. Now, I mentioned it in the Hello World contract.
Yes.
Yes. So now we want to modify this state variable. And because we are modifying it, it is no longer a read operation. Now it is a write. We are changing value. We are changing something. So that way, we still use the same function name, the function keyword rather, the name of the function. Then we specify the visibility type as public. Now, specifying the type as public here, don't forget, we are not returning anything from here. We are only modifying something. So whatever we want to modify is what we specify inside the function. In this case, we are only saying count should increase by 1, right? That's simply what we are doing here. Yes.
I have a question.
So, okay.
In this write Kiniko, why is there no returns?
Because we are not trying to return it. We only want to write to it. Just like you are saying 2 plus 2, right? Then after some lines of code, you are now saying that 2 plus 2 now plus under 5. You don't want to return it. You only want to modify the value at the top.
Okay.
So any function you want to return needs to have the return. But it's not every function that you must return something, right? Sometimes you just want to use a function to modify something and continue your work.
Yeah.
That's what is happening here, exactly. So this increment now, this will increase the count by 1. Then this function will decrease the count by 1.
Okay.
You get it. But there's another thing here. The function will fail if count is equal to 0. The reason why it will fail is because, don't forget, it's an unsigned integer. An unsigned integer means that it must not have any sign. So that means the value cannot go beyond 0. It cannot go below 0, rather. Because if it goes below 0, now it has a sign of negative. But an unsigned integer cannot have a negative value.
Okay.
Does that make sense?
Yeah.
Exactly. So that's why we have this decrease function here. And so Another thing to now see is if you look at the left here, you can see that the functions for reading or the variable that you can read are the one in blue. The ones you can write or the right operations are the ones in yellow or orange. This bright orange, exactly, or dull orange. So now that means if I look at this now, this is a read operation. If I get this, right, the count here is what? Is 0 by default because I'm not initializing it. So by default it is 0 because it's an unsigned integer. The default value for unsigned integers are 0. So in this case, if I click on any of these two now, you will see 0, right? Because that's the default value. If I click on count 2, I'll see 0. But now let me try to increment the value. In fact, let me try to decrease the value first. Like I said, it can't go below 0, right? If I click on decrease here, see what happens? It fails. Why? It says error occurred, revert. The transaction has been reverted to the initial state. Exactly. So it's not telling you what it is, but you also need to know that because I am specifying it as unsigned integer, it cannot go below 0. Because unsigned integers are just numbers from 0 to infinity, but not below 0. Do you get now? So let me try to increase the value so you can see that one works. If I get the value now, it is 1. If I get the count, it is 1. If I increase it again, if I check it again, it is 2. If I check it, it is 2. Do you get it now? So we are simply using this increment to increase the value. If I decrease now, it will work because it's not 0 yet. It is 1. Do you see it? Does that make sense?
Yeah.
Exactly. So now this is a structure with basic contract with read and write operation and with data type specified like this, a visibility like this, and you can see all of those things. Now, one last thing before we wrap up for today now. If I change the visibility of this now to, let me say the visibility of this to private, right? And I run this again and I deploy contract 1, yes, and I deploy this. Now you can see I'm not going to get count anymore.
Yeah.
Do you see it now? Because it's no longer public. It's now private. It's not public to everybody. That means not everybody can call it. The only people that can call this count here is the functions within the contract. You can see that I can still call it here. I can modify it here. I can do anything, but I can't see it outside the contract. It's not accessible outside the contract.
Only abstraction.
Exactly. Do you get? Yeah. So the public private stuff, we talk about them. They are visibility modifiers. So we'll talk about them eventually in more stuffs. But for now, the idea is that they are private, and that's basically all you need to know. Private, public for now. So when we do more advanced stuff, you will see more way to use it, tweak it, all of those things eventually. So yeah, that's basically the idea. So now this is a smart contract to like increase, decrease, all of those things. Yeah. So that's basically it.
I feel so like
you can copy the code from here too, from the docs I sent to you. You can copy it and tweak it yourself and just play around with it. So in the next time we meet, we just work with other stuffs.
Wow.
Yeah. So yes, that would be.
I feel like kneeling down to say thank you.
Yeah, I'll beg you.
Like seriously.
Very good.
Thank you so much.
No while, bro.
As it PC Sam. Jesus. Please, you send me the record though.
Yeah, sure. Once I get it from Google, I'll send to you.
Thank you so much.
The call. Yeah, they will take time to process it. So when they process it, I'll send it to you so you can have access to it.
It's all right. God bless you.
Amen. You too.
And please. Will you be available to pick up a project?
Which one is that?
Okay, outside that personal project that I wanted to build, you understand?
Yeah.
Somebody called me for a project, so I pray it works. If it works, you'll be available now.
Which kind of project? Front end or back end?
Which one you would like take?
Front end.
I'm gonna give you front end. Yeah, thank you so much. I sincerely appreciate it.
No problem.
God bless you. Bless you.
You too.
Amen.
All right,
Please
now
don't
thank
forget this link. Oh, ma go through. After I sleep, they carry me for the meeting. But I understand.
the recording.
Yeah, the recording.
Yeah, sure. I will send the recording once it's available. It can't be available immediately now, but once it's available, I'll send to you.
Yeah, thank you, sir.
Thank you. Thank you too. All right now.
Yeah, bye.
Yeah.